Hi guys,
and welcome to Learn Electronics Repair.
What's happening here? Is this a reversal of roles?
I don't know. This chef feels like home right now.
Yep, Des is home here, so we have a box full of PCBs here from PCBWay. And we thought we'd show you today what we have, and we're going to complete some projects today. So we're going to complete 2 projects, finished, done with, yeah?
I love when we complete projects. Yeah?
Absolutely. So what's in the box? Well, we have the version 1.5 of the op-amp tester. The ominous op-amp tester.
Yeah, the ominous voice. You know, when I named this thing, I was right with the ominous one, right?
Yeah.
Yeah.
So
and revision 1.5, well...
Well, I'm going to show you guys because revision 1.5 actually works. So revision 1, if you guys remember, it did work, but I had some of the LEDs physically in the wrong position. I kind of bodged it and it worked. Then Det came along and changed the wiring and then it didn't work. So
we wouldn't want to talk to this.
Yeah. So
and you had the thing with the auto router on this, where the auto router messed up. Yeah.
Exactly.
Yeah, so
oh dear.
This was this is some progress. Yeah.
It is. But guys, this one actually works. I mean, these are very nice PCBs. They're 1.6mm PCBs. Mm-hmm. Very solid.
For this kind of project, this is absolutely needed to have something that's sturdy.
Yeah.
Yeah, the 1mm is normally my choice, but this will live probably naked like it is on your bench. And,
yeah, absolutely.
Yeah, you need something sturdy there.
Okay, so I mentioned that these do actually work, and I'm going to show you that. And you may also wonder, why do I only have 4 and not 5? It's because I actually built one. So here it is, the ominous op-amp tester 1.5. So with this, you can test single op-amps, dual op-amps, single comparators, dual comparators. You can test quad op-amps, quad comparators. We've mentioned before why we have 2 different sockets for the quads. It's because the pinout is different between an op-amp and a comparator in the quad package. In the dual, the pinout's actually the same. And you may wonder, what's the difference? Well, the difference is, as I figured out when I was designing this, that an op-amp has an output that can go between either voltage rail and anywhere in between. With a comparator, it's just an open collector or open drain output. It can sink current, but it can't source current. And you're going to see that when we test this. These pads here and here, these are for easily testing surface mount devices. This one is for the 8-pin inline dual op-amp packages we get, especially audio circuits will have these type of op-amps.
If you're looking for the pinout, down there is the pinout you have on this
connector.
socket.
And actually, if you look closely, you'll see the pinout is exactly the same as the tail. It's just one above the other. Yeah. And then we have, obviously, for the quad op-amps, quad comparators. And the last thing is this little breadboard. So the idea is here, if you have some device in a package that won't fit into any of these sockets, it's different pinout. You can use DuPont leads, you can stick it in here, you can just move and insert the leads where you want.
If you've got something exotic there.
Yeah, and make a package up. And I'll talk about that in a moment as well. But first of all, let me show you this working.
How many times did you build this PCB now?
3. And it wasn't my fault either.
Somebody who shouldn't be named is a guilty one here.
Yeah. So 3 attempts, but this one actually works. So today we're going to upload this as a shared project, and you guys can download and build these. So I'm just going to show you first. I have some op-amps here. I'll just show you what I have. So these are single op-amps, 741. The ubiquitous 741.
Even I know this one.
Yeah, OP07, that's a very accurate instrumentation op-amp single. And we have some dual, so we have the LM358. This one's actually a comparator, 393. BA4558 and this 4560 and various. These are very common audio op-amps. LM358 again, I have a few of them on there. This is that package I was telling you about. Look, BA4558 in the inline package. And then I have a few quad ones. So TL084, which I think is a JFET input op-amp. TL074, LM339. This one is a quad comparator. LM324, very common op-amp. So let's just test these and see what happens. The tester runs from 9 volts. You can run this from a 9-volt battery. I'm going to use my bench power supply, so I'll switch this on now. And you'll notice that these light up. They're actually dim. My camera shows them as being bright.
Yeah, but it's pointing at the thing. Yeah.
Yeah, but they're actually quite dim. If we flick the switch from sync to source, we get the red ones dim, okay? So let's put one of our 741 op amps in here. And you'll see, module 1 is flashing. So this is a single op amp. It only works module 1. This little switch, by the way, sets between 50 milliamps and 20 milliamps. That's your test current. If we switch this switch to sync, it's now syncing current. So that tests the op amp both ways. It can supply current, it can sync current. And that's how easy these are to test.
So now you know this op amp is fine.
That op amp is fine.
Okay.
This is the OP07. Again. Just plug it in. Flashing, yeah? Sync and source. And you can, by the way, if you guys have wondered, if you put the op amp in back to front.
I was just thinking this.
Yeah. If you put the op amp in back to front, it's not doing anything now.
Did you kill it?
No, I didn't kill it. Because if I take it back out, we put it back in the right way round.
Oh, it's still blinking.
And it's still blinking.
Yeah.
That's because we have the current set very low. So it won't sync or draw. I mean, this current's not only flashing the LED, it's powering the op amp. So you can actually put them back to front, guys. It really doesn't matter.
But how does this do the blinky thing without having a CPU or something in there? Because me, the digital one.
Well, the schematic is in the download, so there'll be a link on the project, guys, download it. But basically what this is doing, it's forming an oscillator, it's charging and discharging this capacitor and switching the output. So that's basically, it's just an oscillator circuit.
And you're using this to check if the function is there.
Yeah. So effectively this is testing the function. So effectively when one of the inputs goes above or below the other one, the output switches and then the switch sets it to either sync or source current. So that's how it's actually doing. It's just literally an oscillator.
Yeah. And we have this 4 times for maximum quad op amps.
Correct. We have it 4 times. So we'll do that right now. I'll show you if we take this out. We'll put in a dual op amp into here. Yeah. There's 2 of them flashing.
Oh yeah, because you can see they getting out of sync because parts.
Well, there's tolerances. Yeah, I mean these capacitors are a 10 microfarad. They're not close tolerance. So yes, they'll go in and out of sync. They're completely independent. Again, so that op amp's good. We'll just try another one. And you notice you don't need to power this off when you're doing this.
Yeah, this is hot plug.
Yeah, hot plug. You just literally plug your components in. In fact, if you get it right, you can just kind of like just rest it into the slot. Okay.
Sometimes.
Now this one is a LM393, and you'll notice nothing's happening.
Oh, yeah. Nothing's blinking.
Okay, that's because this is a comparator, and a comparator cannot source current. It can sync current.
So you have to know this, and you maybe want to always try the switch. By the way, the switch is the only part in here that isn't standard. We needed something with 4 ways, so this is a bit hard to get. I think you had a link for AliExpress somewhere.
Yes, I do. I have a link. And we have the bill of materials also.
We have the bill of materials, yeah.
Yeah, but I will check, guys, and make sure you have the link for the switch. It is the only slightly uncommon thing. I mean, to be honest, if you didn't want this easy switching, you could just put some jumpers here and just set it to either sync or source. Yeah. But we got 5 of these switches for not very much, a few euros. So anyway, so you notice with the comparator, it will only sync. Again, this is a matter of knowing the part number or just looking at the data sheet to see what it is, yeah?
Yeah, this is normally what you do before you put this in there. You have a look. This is a one single or dual one.
Correct.
If you don't know the part number, you simply check the data sheet.
Absolutely correct. Yeah. So you can see they're all working fine. We can try also the inline one.
The weird one, I would say.
Yeah, if you repair mixers and amplifiers, these are not strange. These are quite common. But look.
Yeah, and it does a thing, yeah.
Just hold it in position. Again, it's an op amp. Syncing and sourcing. Huh? And we'll do some quads and then look at the surface mount ones.
Oh, yeah.
So let's try some quad ones. What do we have here? This one is a TL084, which is an op amp.
Yeah, and now we have a full light show.
Yep, full light show, all flashing. So it's so easy to test these devices. We have a few more. This one is a LM339. This is a comparator. Now, I'm going to put the comparator into the comparator slot, but then I'm going to try something. I'm going to put it into this one. Just to show you guys. So, again, that's syncing, but it can't source.
Because it's open collector.
But it's open collector. Now, and it's also a different pin out, by the way. So we have two sockets. You see, here we have one out up here, the same, but then you have two out rather than one in, and so on. So you guys are going to ask me what happens if I plug the comparator into here. Yeah, because you can do these things easily accidentally. So we plug the comparator into there. Doesn't do anything as such. We can take it back out. We put it back in here. Yeah. And it's working just fine.
So if you get to a point where you think, okay, this doesn't work, and I'm not sure if this is a comparator or a normal op-amp, you have to look at the data sheet. Yeah.
But if you plug it into the wrong socket, you're not going to damage it.
Yes, this is the current limiter that we have.
Again, the current limiter. This is why it's probably best to leave it on to 20.
Yeah, true.
But if you, for example, want to know if the op-amp can supply more current, you can switch to the 50. And the currents, this is an LM317. So the currents are set by these two resistors. So if you have some specific reason to test op-amps at 100 milliamps, for example, you can change the value of the resistor.
Yeah, sure.
Yeah, so this is why this thing is so flexible.
Yeah.
You can just clip a resistor in parallel with the existing one.
True. Yeah.
Yeah. So that's why it is so flexible.
If I run into something really exotic where I know the schematics, I know the pin out, but I can't fit it in somewhere into our schematic there, I can always use the breadboard.
Absolutely, yes. So this thing here. So DuPont leads, plug your device in there. And while we're talking about this, you can also fit these. So these are like the adapters you would normally get with an EEPROM programmer. And you can buy these adapters separately, and you can put them into here and then clip your devices in.
Oh yeah, this fits barely, but it fits.
Yeah, yeah. And again, you could fit something like a ZIF socket.
True.
Take a ZIF socket, fit a ZIF socket in there.
So for a very exotic design, you don't know, and you have to test lots of them. This is probably the way to go with that.
Yeah, exactly. And again, because all the inputs are marked, and these are the same, so these just duplicate. You see, they're the same. It's just so you can bring leads in from one side or the other easily. They're not all kind of like going over the top of your sockets. Yeah. So this, guys, it really is extremely flexible testing. Let's have a look at a few SMD devices, okay? What do we have here? This one is LM393. That's a dual comparator. This one I have is a LM358 dual op-amp. And these two I think are both the same. So LM324 and LM324. But notice this is a wider package than this one. But they'll both fit onto the PCB. So first of all, let's go to the dual ones. There's only one standard pin out for these. And this is where having this current limit comes into place, because you really don't have to worry as you slide this up onto here.
Oh, and then you simply
if you have it right, then you simply hold it down with your finger.
Oh yeah, and I can see this is not in shot right now, but
yeah, flashing green. So that one is a comparator.
Oh, okay.
Yeah. It will only sync. The other one is the op-amp. And again, the same, if you accidentally put it upside down, you're not going to trouble it. I'm not in fact sure which way this one actually does go up. Let's have a look at the chip.
I think it's 180.
Yes, 180 on that. But it's the fact it's lying on here, you're not going to bother this any. Again, we just get it into place and we push down on it. If you were testing a lot, I would suggest you get the ZIF socket and plug it in there, or the little clamp type socket. So again, we push down on this one.
There you go! Yay!
Yeah, again, so just push down, sync or source. That's that. Now let's just try these quad ones, because I happen to know one of these quad ones is faulty. One I prepared earlier. So we know they're both LM324s, they're both quad op amps. We can stick them on here. This one I'm sure was actually the good one. Just get into position and then you get all four flashing.
Yeah, you got it.
Okay, so that one is working. We can see that is all flashing all four. Yeah, I'm just losing the contact a bit. You could try putting a bit of solder onto these pads to make them a little bit softer.
This is a bit fiddly, yeah.
It is a little bit fiddly, but we can see it works.
But you know, this is the fastest way to test these.
Yeah, absolutely, absolutely. If you have lots of them, just get one of the little adapters. Just use an EEPROM program to stick it into there, into a little clamp. This one I tried earlier, and this one does not work. It'll fit across the pins okay, but I can only ever get 2 of them to flash on it. You see there? No matter what I do with this one, I could not get the other ones to flash.
I'll probably use one of my reverse tweezers for this to clamp it down there.
Oh, those things. Yeah, let's try this.
Yeah.
Okay, Detlef just came up with another suggestion. Use a crocodile clip.
Or reverse tweezers if we have one.
Or reverse tweezers.
Yeah, some. I use normally ceramic ones, so.
We can see this does nothing.
Yeah.
And you can do this, by the way, because the back of the PCB, well, no pads on there.
Yeah.
Okay, so that's the op-amp tester working. What we're going to do now is upload this project onto PCBWay.
So you good folks can have a look at this yourself if you're interested in this.
Yep, let's do it now.
Yep.
And here we are on PCBWay.com. So we're going to create a shared project. Into shared projects, create a project. And this is where we put the various information. So title. Okay, so we have a description. Actually, you put 150 characters. You can get quite a long description here. So this is the name of the project, Universal Op-Amp Tester, SMD and through-hole. I've noticed with the search on PCBWay, if I only called it op-amp with a space, and somebody then was searching for op-amp without the space.
Ah, this is why you had the difference.
This is why I put it in twice.
Yeah, nice.
So how would you categorize it? We have various categories here. Unfortunately, there isn't one for test equipment, so I just put it DIY electronics. Yeah, but we can choose more than one. So, for example, we can put this down as DIY electronics and audio, for example. Op-amps use a lot of audio.
True, yeah. People will find this if we're looking for audio.
Okay, so there's some categories. A short sentence that says it all. So in here, I'm going to put something like find this project on electronics repair. I won't put the links here because I have a place later to put links.
Okay.
So I'm just going to say that in there. Continue. Add Gerber file. So
oh, there are the Gerbers. This is nice.
Yep. So this is the Gerber for the op-amp tester, version 1.5. Open. Now we can upload some pictures. Here's one I prepared earlier. Noticing that the aspect ratio doesn't quite want to fit this. Okay, we have a slightly dodgy picture there. Okay, that works. We won't use the preview one. Okay, we have a picture of it now. Okay. Then, now we can put all the components in here, but I've uploaded a bill of materials to my Google Drive, so I don't need to do that. Okay. I don't need to upload the parts list.
Oh, no, yeah, right. This would be for the... But since it's all through hole, there's no real sense in doing this. But we included a
bill of materials, a schematic and everything for you guys. So again, we didn't use any software. There's no firmware here. So now we can put a project description. Okay, guys, so I've linked to the various videos that we made on this. This one explains the actual circuit design. If you want to see, as Det asked, how does this work, you'll find the information here. This is the PCB design. We made a couple of videos about that. And then everything you would want, schematics, Gerber file, bill of materials are here. So we can now submit that. And we have a project for you guys to download.
I think we have, yeah.
We certainly do. Okay, and there it is. So that is one project completed. I will put a link to this project in the description to this video so you can find it easily on PCBWay.com. So as you see, guys, this one is ready now. You can order your PCBs. And as a bonus, if you yourself want to design or upload projects like this, and someone then comes to download your projects, you get 10% commission from PCBWay. So yeah, you can make some money from this. Okay, so we said there was something else in the box. Let's have a look. Well, we have two more things in the box, but we're going to talk about this one. So this is the sweep generator, Uncle Sweepy. Now, I know we actually finished this project. We already uploaded a shared project, But some of you guys out there were asking us to make this a little bit more useful, shall we say, or rather flexible. So you wanted to be able to attach the display, the rotary encoder in different directions to get this to fit into a case. So what we have here is actually a remade version of this PCB, and I have the old version here. So Det's going to take you through this one, explain what we have, what we changed, and then we're going to show you how to edit an existing shared project of your own on PCBWay.com.
Okay, so you see revision 0 and revision 1 side by side here. So, and this is more an evolution. This is not something where we go, oh, we add something. Well, we added a bit of functionality here, but revision 0 really worked. And for revision 0, yeah, I was pretty proud of this.
Yeah, in fact, we have an assembled one.
Yeah, because revision 0 never works normally.
Yeah. In fact, here is the assembled revision 0, and we had this working on the previous video.
Yeah, so if we want to watch what's this doing, go back to the other video, because would be moot to explain again.
Exactly, and also to make it easy for you guys, I will link the previous video.
Yeah, please do. Yeah. And what we did was actually we listened to you, and actually thanks to Chris Hartley, Tim's Projects, of course, and Ellie Jackson, you had some suggestions on the last video where we thought, okay, this absolutely makes sense, and why didn't we come up with this? Yeah. But sometimes you need to discuss with people, and this helps for evolving these projects. So this makes it better.
So if there isn't much difference then, I mean, I can see a few extra holes in here, but what did you change that?
So we actually added a second row for the displays, because you can mount the display like we did on this one. Like that, but some people suggested, okay, we want to have this 90 degrees tilted, so we can have it in front of a little thingamajig.
Oh, yeah.
So, and for this, the display needs to turn 180 degrees, and yeah, this is what we did here. So one of the lower ones is actually a turned display thing, where you have the display 180 degrees turned around. Okay. This was a bit fiddly with the connectors here, because you know these displays come in all different connectors, and you probably want to measure this when you have your display there. Before you want to connect this here, you have to read up which one you use here. Just use a multimeter, just go for continuity. Yeah. The same we did with the rotary encoder. Yep. And we simply switched it around. So this is actually mounted this way around, but now you can mount it 90 degrees. Oh, so you can actually have it above the PCB or below rather than flat like this, which is probably easy to fit onto a front panel. Yeah, absolutely. Yeah. So this is up to you if you want to have this on your bench, just flat like this one here. We're using this more like this. So, but if you want to have this in a little enclosure and you want to have these standing up, these display and the rotary encoder, you can do this too. Okay, so I see something else here that which says rotate display 180 degrees. This is a small software change, really tiny one. It's 3 lines. But when you mount the display in 90 degrees, you turn it like that, 180, and then pull it up. So the display will be upside down. Upside down. This is a word. It should be good enough for Australia. Yeah, it would be. Yeah, in Australia this will work, not over here. So we needed some way to tell the software, okay, the display is mounted upside down. And since I didn't want to have everybody go through the source code and figure out how to do this, we have pins left. I simply added a little jumper over here. If you mount the display upside down, you simply cross this little jumper and it turns the display 180 degrees. Oh, so by fitting the jumper or not fitting the jumper, it will just rotate the display. Yeah, you could use a jumper. I'd probably, because this would be something where I want to have this way around or the other way around. Yeah, I simply drop a blob of solder. Okay. You could use a jumper if you want to be very, very flexible, but I normally simply drop a drop of solder on there. Okay, nice. This were the changes here, and again, thanks to Chris, thanks to Tim, thanks to Ellie for suggesting these things. Oh, excellent. Okay, Dad, so we only have one of the original versions built, but you've put the new software on this, I believe. Can you actually demonstrate this rotating display on this one? We can do this. Yeah. Great, let's try it. And by the way, if you ordered the old PCBs, there's no problem there because the software is compatible, so you won't see a change there. This runs right from the USB port on the Arduino. It takes all the power from there. And we can see track 1. Yeah, track 1. And now I'll have magically prepared this thing here. The 11 should be here. So this is only red when the CPU resets. Okay. So reset. Oh, and it's flipped. And it's flipped around.
Right.
This is what the little jumper does.
Yeah, you're just simulating what the jumper does.
So D11, so this pin, if this pin goes too low to ground, then, and it boots, it reads the pin and it can tell, okay.
Okay.
Yeah.
In fact, if you built the original PCB, it'd be very easy to include this. Yeah. And to make this even easier for you, what we've done today is we've updated the link on the Google Drive. So it's still the same link as you had before, but you now have the updated version of the software on there.
Yeah, but you need to update the Gerber, right? Because the new Gerber...
We certainly do. So what we need to do now, we want people buying any PCBs from now to buy the new version. So to do that, we need to edit an existing PCBWay project. Let me show you how to do that.
Oh, yeah.
So to do this, we just need to find the original project. I mean, the link is in the previous video, but we can also do a search for this. And we called this one Uncle Sweepy or Audio Sweep. So if we just search for that, Audio Sweep, we can find it. Okay, there is our original project.
I see.
Uncle Sweepy. So we click on the project. I'm actually logged in on my account. So I now have an option to edit this. You can only edit your own projects. So edit project. And I don't need to fill anything in. It's all here for me. But what I can do is add a Gerber. So this is the original Gerber. We can get rid of that one. We can add a Gerber. We can put the new one in, which is this one. Open this. And we've now uploaded the new version.
So this is easy.
Yeah. The reason it didn't change the picture here is because this is just a photo. This is not the Gerber.
And we really don't care about this.
And we really don't care about the photo. So we now just submit that. And we've now updated that project. So if anybody or yourself comes along here now, here's all the links. Here's the schematic. This is a link to the video and everything's there. And if you go back to the old one here, it will still work. It's the same link. You'll just get the new file.
Again, no problems with the old hardware and new software. You can mix this up as you like. If you put the old software onto the new PCB, you won't have the rotate display.
Yeah, it just won't work.
Yeah. But it won't break the rest.
Okay, guys, so you can't really go wrong with that. You'll also notice I have rather a lot of PCBs here for the revision 1. This is because on PCBWay, you'll see when you order PCBs, you normally have the option for 5. But if you're ordering small PCBs like this, then you can actually change it to 10 at the same price.
Nice.
This is something one of the subscribers actually pointed out. So thank you. I don't quite just recall the name, but thank you very much. So guys, with small PCBs like this, you can order 10 at the same price as 5. If it's a bit larger, you'll find that if you order 10, you don't pay double, you just pay a certain amount more, depending on the size of the PCB. So that is another project now completed. And we have one more thing in the box. And this is some white PCBs. Milliometer, but this is something new. So you know what, guys, we're going to leave you hanging on this one. Thank you for watching. We have 2 projects completed, and very shortly on the next PCBWay.com video we'll talk about this project and the milliometer we already bought. Oh, and one more thing we're going to talk about, and that is the RF generator, which we also completed. Okay guys, hope you enjoyed that. Look forward to seeing you soon.
Ciao for now.
Ciao for now.